Alright, so I wanted to do a couple more examples of the law of sines and the law of cosines. So I've drawn a little triangle here. We know that this angle here, angle A, is 41 degrees. This side is 22, and this side is 31. So this is a law of sines problem. So you might want to know, how did I know that? Well, I know angle A, and I know the side opposite that. So anytime you have a pair, like you know both angle A and side A, that's a big clue to use the law of sines. So we know that the sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. So that's what the law of sines says. So we're going to plug in what we know and see if we can solve for something here. So we know the sine of angle A is 41 degrees, over side A, and we know nothing about angle B or side B, so I'm not even going to bother writing anything down there. We do know side C is 31, but we don't know what angle C is. We're going to have to solve for it. But we can set up this proportion here, and that gives us an equation to use to solve for angle C. So the way you're going to do that is we need to get first sine of C by itself. I can do that by multiplying both sides of this equation by 31. So the 31's on this side are going to cancel out. And over here I'm going to get 31 sine of 41 degrees over 22 equals the sine of C. And so from there, I'm going to start using my calculator a little bit. So I'm going to type in what I know. I know that I've got 31 sine of 41 degrees over 22. So I get this nice decimal here. You can make that out. 0.92444,68136. So it's not really important that you write down all those decimals to show work. Just write down a couple, but you do want to save this number on your calculator, so don't press clear or anything. So we'll need that here in a second. So we just saw that the sine of angle C was this nice pretty decimal, 0.92444 ... It goes on for quite a while. So we want to figure out what angle C is. So I need to I need to undo this sine operation here. And to do that, I'm going to do the inverse sine of both sides. So when I do that, it cancels out the sine there, and I get the inverse sine of that nice pretty decimal, 92444 ... And then again, I'm going to go back and use my calculator to type that in. So I'm going to bring up the inverse sine of that same answer that I just put in. So the keys I press to do that are second and sine if you're using the TI-83, and then second and the negative key will bring up answer. So that's going to tell me what's the inverse sine of this answer that I had right above it. It comes out to be that angle C is 67.585. So I now know angle C is 67.585 degrees. So that tells me what this is down here. So from there, I can now find another piece of my triangle because I know that it's a triangle. There are three angles and they have to add up to 180. So if I take 180, my calculator, and I subtract what I already found, I already know that there's one that's 41 and one is the one that I just found. I'm still in my calculator. So I type that in and I see that the other angle has to be 71.415. So angle B is 71.415 degrees. Alright, so we didn't have to use the law of sines or cosines to find that. Just a little bit of knowledge of triangles. But we will have to use the law of sines again because we need to find what is this side here. So I have to set up another proportion using the law of sines. I know that the sine of 71.415 degrees over side B, which I don't know, would be equal to the sine of 41 degrees over side A, which is 22. So this one, I need to get B by itself. So I'm going to take this proportion, I'm going to cross multiply. So to get 22 sine of 71.415 would equal B times the sine of 41. And then to get this B here by itself, I need to divide both sides by the sine of 41 degrees. So dividing both sides there by the sine of 41. I see that the sine of 41 over itself over here is going to cancel out. I'm just going to get B on the right side. I'm trying to block out the light there so you can see what I'm actually writing down. Hope it's helping. So B is going to equal this this number here. And then to find that, I'm just going to type it into my calculator and let it spit out an answer for me. So I got 22 sine of 71.415, and I'm dividing that by the sine of 41. So I'll type that in there, and I see that side B must. Alright, sorry for the break there. I had a phone call I had to answer, and I'm trying to record this on my phone. So we'll continue with this. Again, we're just typing this number into our calculator. We had actually gotten the answer already. It was 31.785. So we now know that side B here is 31.785 units long. And that's everything on the triangle. So we'll stop that one there. I also wanted to do an example here of a Law of Cosines problem. Turns out that Law of Cosines are pretty easy to recognize. They show up anytime that you know side, 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 or side, angle, side. So either of those two scenarios where you know either side, 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 or side, angle, side, that's going to be a Law of Cosines problem. So let's do one. Let's say 479. Let's say I know this here. So I don't know what this side is over here, and that's the first thing I want to solve for when you're using Law of Cosines. So I know that that side there, when I square it, that's going to be equal to the other two sides squared and added together minus 2 times one side times the other side times the cosine of that angle that I know, cosine of 70 degrees. Alright, so I need to solve for this, and I can type all of this mess into the calculator and let it do it for me. There's no real magic there. So I said that x squared was equal to 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of 70 degrees. Type that in there and I get 72.375. So x squared is equal to 72.375. When I find x, of course, I have to take the square root of that number. And I can do that on my calculator as well. I know by approximation it's going to be about 8.5, roughly. Wow, that's actually pretty dang close. It's 8 and a little over a half, 8.507. So 8.507. So this side over here is going to be 8.5 units long. 8.507. And then once I know that side, I don't have to do the law of cosines again. I just have to do law of sines from there out. Let me jot down the formula for law of cosines in case you need it. Looks like this here. Alright, this is one of the three. There's actually 3 different ones, and they're interchangeable depending on what angle or what side you're looking for. I didn't label this on purpose, so I could just show you the relationship for how to figure out what to do with the numbers. So again, from here out, we can just use law of sines, because I now know this angle and the side opposite it. So the sine of 70 degrees over that side I just saw for 8.507 would be equal to the sine of one of the other angles. Let's say you want to find this one. the sine of theta over 9. And I want to solve for theta there. So I'm going to multiply everything here by 9. I'm going to get 9 sine of 70 degrees over 8.507 equals the sine of theta. And then to get rid of that sine again, we do the inverse sine, and we can do that on the calculator. So I'm going to find the inverse sine of 9 sine of 70 over 8.507. So it comes out to be 83.799. So that angle there is going to be 83.799 degrees. And then once I know that angle, I can subtract that and the 70 degrees from 180 and find the missing angle that I don't know. So 180 minus that number minus 70 degrees leaves 26.2 to be the other side, or 0.201. So this other angle here would be 26.201 degrees. So there's another triangle that we solved. So hopefully you've seen enough examples here of law of sines and law of cosines to kind of figure out what you're doing. Again, it's really helpful if you make yourself a table so you can look and see do you have a pair or not, or if you just learn to recognize the triangles. So again, anytime you know side, 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 that's a law of cosines problem. And also, knowing side angle side is another one. So those two are both examples of when you'll do the law of cosines. Law of sines is pretty much everything else. As long as you know a side and the angle that's opposite it, you can use the law of sines. So just a little note there. Be really careful when you're typing this stuff in that you're in the right mode. So for example, if I wanted to find the sine of 70 degrees, that's vastly different from the sine of 70 radians. So let's look here for just a second. The sine of 70, when it's in radian mode, comes out to be 0.7738. And then if I change it back to degree mode, the sine of 70 degrees is 0.9396. So those are very, very different numbers depending on which mode you're in. And that occurs because there's a vast difference between 70 radians and 70 degrees. To illustrate this, we can look at, let's say, hypothetically, this is a 2-degree angle. 2 degrees is not actually this big. It's actually much, much smaller than that. But let's say, hypothetically, this is a 2-degree angle magnified several times, so we can actually write a 2 in there. And then look at 2 radians. 2 radians would be more like something like this. So obtuse versus very, very acute. There's a huge difference between 2 degrees and 2 radians. So be really careful that you include your degree mark to show that you mean degrees. Otherwise you might miss some points on the test. So that was a couple more triangle problems. Hopefully they're beneficial. If you want to see 1 or 2 more, just let me know. I'll make another video. So hope that helps.